As a child, we all believe our hearts looks like the pretty pictures of hearts that are all around during Valentine's Day, or even if we were to write a love note to someone. Around the tender age of about 9 or 10, we learned that our hearts look like this, which is roughly about the size of our fists. Even though our hearts were broken, this vital part of our body does things unimaginable.
The human heart not only is in the center of our body, but it also pumps blood throughout our body and helps our body function by providing it with oxygenated blood. With the assistance of modern technology and thanks to Willem Einthoven, hospitals now utilize a machine called the heart rate monitor since 1903.
Since technology has drastically advanced since 1903, the heart rate monitor, or EKG, is used in every hospital across the country as a way for medical staff to monitor the heart rate. As odd as it may seem, an EKG and physics correlate. Weird, right? Before we go any further in this video, we feel we should educate you about some key vocabulary. First, we're going to start with some anatomy terms, then later we'll define a few physics terms we'll be using.
Right atrium and the left atrium. Both atrium collects blood from body tissues, except the right atrium collects deoxygenated blood from the body tissues, while the left atrium collects oxygenated blood from the lungs' arteries and directs it towards those body tissues that need the oxygenated blood. The right and left ventricle. Both chambers collect and expel blood received from an atrium and moves the blood toward the tissues or lungs.
When someone is hooked up to an EKG, their heart rate appears to look like this when they're calm. But when someone is surprised, under any type of influence of drugs, or even exercising, their heart rate would look more complicated than the first graph.
While the EKG simply looks like a bunch of weird lines, each group of waves represents what's occurring in the heart. At the P phase, the atrium becomes full of blood. After the heart beats, it then moves on to the QRS complex, which is when the heart pushes blood from the atrium into the ventricles. After the heart pumps the blood from the ventricle, the T wave occurs when the ventricles are recovering and preparing for another cycle.
QRS complex, a group of waves depicted on an electrocardiogram or an EKG.
Here's where the physics comes into play. The lines you see are called waves in physics, even though they appear to be weird lines. The terms we'll be using to explain the physics principles that relate to this graph are frequency, wavelength, the period, amplitude, a crest, and a trough. The period is the time it takes to complete one cycle. The frequency is the number of cycles or oscillations per second. The wavelength is the distance of the wave pattern before it repeats. The crest is the top of the wave. The trough is the bottom of the wave, and the amplitude is the maximum displacement from a zero value or rest position.
Here is an example of the wavelength. Here is an example of the crest. Here is an example of the trough. Here is an example of the amplitude.